In Module 4 of Chapter 12, we're going to introduce the notion of option elasticity. Elasticity is a notion from economics whereby one relates percentage changes in two different contracts. In option analysis, the Greek letter used for elasticity is omega. This is a capital omega here. And it describes the risk of the option relative to the risk of the stock, but measured in percentage terms. Delta is the measure of risk of the option relative to the risk of the stock in dollar terms. Because recall, delta is by definition the change in S, change in the option divided by the change in S. So delta is the dollar measure of relative risk. In contrast, omega is the percentage measure. How does 1% change in stock price convert to a percentage change in the option price? So if we just do the math, the definition is omega is the percent change in C over percent change in S, and you can just follow along. And what is the change in C? As we just saw, the dollar change in C is the dollar change in S times delta. And we do the math, and here we have it. Namely that omega is the ratio of stock and option prices times the delta of the option. So as an example, and this is an example 12.8, if we have a stock with a price of 41 and we're looking at a call option with a strike of 40, as we've seen a number of times, we'll assume a 30% annual vol, 8% risk-free rate, and it's a one-year option, no dividends payable on the stock. What's the elasticity of the call? Well, the delta of this call is 0.69, as you can see it here. Namely, a dollar change in the stock creates about a 69-cent change in the price of the option. But the elasticity is quite a bit different. It's the ratio of prices times delta. And we see it's 4. In other words, what we're saying is that if the price of the stock changes 1%, so that would be from 41 to $41.41. If it changes by 1%, the change, the stock price, the option price will then change a little more than 4%. So it'll change from $6.96 to that plus 4% of that would be about 25 cents. Okay, so it's a different measure, reflects the same idea, but it calibrates this relative sensitivity in percentage terms. On the put side, it's negative. The delta is negative, negative 0.3. A dollar change in the stock price creates about a 30% change in the put price, but when we do the calculation for the omega, we find that the omega of the option, of the put option, is around -4. So if stock price goes up 1%, the put price goes down about 4.39%. So if we look at the we next want to talk a little bit about this general expected return on the option. This came up before in the analysis of pricing an option with real rates. And so we'll look at this a little bit more. So remember by our original pricing formula that the price of a call, or the price of any option, is the price of the replicating portfolio. And that is the cost of delta shares and a T-bill position of B dollars. So that's the price of a C. So if alpha is the expected return on the stock, R is the risk-free rate, and gamma is the expected option return, we can express the formula we had before in terms of the option's elasticity. It says that gamma, the return on the option, which could be thought of as a weighted average of alpha and R. That was what we did in the earlier module. We can also do the algebra here to express this way. It says that the return on the option, the expected return, is the omega times alpha minus R is the so-called risk premium, the stock risk premium. If you take the return on a risky security and subtract the risk-free rate, that's called the risk premium. So what it's saying is that the return you get on the option, the expected return, is the elasticity measure times the risk premium plus the risk-free rate.